Good afternoon, everyone, and thank you for coming for this afternoon's Spark session. We are presenting two ideas from the frontier of data center management. I'm pleased to welcome our two speakers, but first, my name is Sean Tulliver. I am a senior conference producer for Data Center World and the host for your Spark sessions at this year's conference. And I'm excited to kick off this session, the two ideas from the frontier of data center management. If this is your first Spark session at the conference, let me explain the format. For this session, we have two speakers who are delivering two big ideas in 45 minutes. The Spark sessions are designed to give you multiple actionable takeaways in the time that it usually is for one presentation. So think of it like this. One idea might be a flicker, but two sparks, that'll be a better shot at starting a fire. So for this Spark session, we are exploring the cutting edge of data center management with our two leaders, Jeff Ziegler, from the CEO of XactAsset, who is going to be tackling how machine vision, RFID, and real-time location systems can transform asset management, and then Peter Sacco, who is the founder of PTS Data Center Solutions, Grey Wolf Data Centers, and Atlas Cloud, who will be talking about exploring why the need for AI inference age needs a data center network that looks more like our electrical grid. So I am proud to present these two sparks from the frontier, and let's see what ignites. So Jeff, I'll turn this over to you.
Thanks. All right, down?
Yep.
All right. Thanks for joining again. I've got about 15 minutes or so to walk you guys through some slides. Excited to talk about it. I think this is the most obvious slide without too much background intro. Obviously, massive CapEx investment. And this whole industry and all the keynotes I saw today so far, it's about build, build, build. And what strikes us is how much CapEx is going into these fleets. And it's staggering pace. And every year we seem to find ourselves saying it's going to be even more CapEx the following year. What's shocking is some of it's not even financed. It's actually on balance sheet. So you have these mega fleets, and I think everybody is joining this investment race, and you've got what is some pretty staggering amounts of fleets that are dispersed across mega campuses and all over. And what we're looking at is operationally, do you know exactly where the fleet is? Do you know what condition? Do you know what the value of that fleet is? And so our position is consider exactly what is happening with all this CapEx and all the investment. And I think operational excellence, knowing exactly where the assets are, what the value of those is, when to refresh, is going to become mission critical. It has not been top of mind because we haven't seen wide adoption. There still are some pretty staggering stats out there. If you just use one of your GPT or any of your large language to do a search, you'll see about 30% of an on-prem data center has ghost or zombie lost idle assets in it. And so it has just been build, build, build. And what's interesting is say, how can we better operationalize this and understand exactly where the fleet is? We're looking at three things today, as Sean pointed out, which is let's look at the value. There are some very exciting agentic tools that can predict the value of systems in any asset in the campus. Location, I'm going to be going over some of the location tracking. I'm going to focus on RFID, but integrating exact location data into DSIM, CMMS, BIM, ERP is one of the things that's really in the early stages right now. It's still a lot of manual effort. And then condition, I'll show you some machine vision inspection that we use that you can do at scale to understand the exact condition of an asset. I think I gotta go back one, guys. So let's talk about location. I just want to be very specific on what we're looking at here. So RFID provides real-time location systems. And what this basically is, if you guys look at the pictures, this is a sensor that's digitized, and it's not only just a label that has encoded data in it. And so you can actually know that's the serial number, GUID of an asset, but you can also understand the build date, the retirement date, serviceability, This has become incredibly widespread. I just posted something this week. UPS is standardizing all their trucks. Most grocers are starting to understand we want to track a muffin in a case and know when to take it out at perishability time. So it's not just a tag, it's an encoded tag with all the asset data. If I want to know that this asset lives in a server, that lives in a rack, that lives in a data hall, all that information is encoded in that tag. The nice thing about RFID, these are printable, they're very scalable, very low cost, highly efficient, and they're easy to manage. And you can integrate them with your CMDB, your entire asset repository. Amazon, Walmart, FedEx, UPS has deployed this at scale, and it's incredibly robust and resilient. So this is not niche tech. It's widely commercial available. Retail merchants are tracking boxes of crayons. When you walk into a data center, you say, how are you tracking GPUs? And they say, we keep a log of them, or we think we know where they are in the rack, right? People are tracking crayons and muffins with this technology, and you can get exact location on all of them. So the tag has all the data and the sensor information in it, and it's unique. You'll see a lot of things out there that get some concerns in the data center, like BLE, ultra-wideband, cellular, seems to be completely verboten prohibited. They're not going to allow anything like that in the white space for sure. Even active tags, they're all great. So you can do UWB for something like managing a mile radius. You can do BLE mesh, which is very exciting. Nice thing about RFID, these are 100% secure. InfoSec will approve them. You can generate them yourselves, and they have all the asset encoded data. They do not transmit. The readers do. So what you see in this picture, we've actually figured out how to tag. Think about any asset in the data center. So think about rack, cooling, pump, power, server, GPU, CPU, memory, hard drive. You can track nested assets too, relationships. So if you want to know at what time a hard drive came out of a U that was in this aisle, very easy to do that fully autonomous. You need no human hands. There's no smart hands that have to manage any of this. That data is real-time data that can be instantly integrated into DSIM and other asset management platforms. So it works on anything in the data center. It won't work all the time. Liquid and metal is a real problem, and people say, well, that's all we've got in the exhibit hall is metal and liquid. There's ways to engineer it so that you get the right reads on it, right? So it is sensitive, but it takes a different portfolio of tags, some of the physics and the readers, but you can get autonomous location from all of these things. You end up getting something that we use on the bottom right, which is a control tower view. If you want to know exactly where everything is in the data hall, on the campus, you could use this at staging, integration, reverse. You can even hook up a 5G reader and say, I want to know every single asset on that truck while it's in transit. And so wherever you have encoded data and you can get a reader, you can get real-time location. Very, very resilient, 100% secure. These are quite easy to deploy. I'm going to show you this. Let me see, how do I hit play? Got a video I'm going to play for you guys. This is a, there we go. Play. Sorry, guys. I think I'm hitting it. So this is machine vision. This is going through our tunnel. This is doing servers right now. This is doing a full inspection on servers that are being returned. We're actually getting a full inventory of every subcomponent, part, and asset in the server. Once you use AI to train the model, you can use machine vision to say, does this match the as-built? Is this conforming? Is there damage, abrasion? Is there substitution? Is there something unseated? If you want to do GPU inspection, looking at microns of detail, it's quite easy to train. This is for some of the tech assets. We've got this to where it's inspecting memory. It's actually looking at that and saying, those aren't just memory DIMMs. I know which memory DIMMs, which manufacturer, which capacity. Can't read the part number. We could with a different vision system, but you can get a lot of intelligence just using machine vision. When you look across data center industry, wherever you have people doing QC inspection, you've got an operator with a magnifying lamp, you can train machine vision to actually replace a lot of that work effort. All of that data can be integrated. It's just metadata like location data. So if you want to take ServiceNow or take a DSIM tool and say, this is the asset, I want the picture of the asset in its as-built and current condition, all of that data can be integrated. We can do this at different form factors. You guys can do this as well with several different technologies. Some very cool applications on whole racks where you look at it and say, is that rack completely configured? Everything's plugged in the right port, components are seated. At QA and deployment, all the way back to end of life, anything you want someone to inspect, machine vision can be trained with AI, and you can integrate that data. It's very efficient and very scalable, and so I think there's a lot of promise. I go back to the first slide. Think about racks that are worth $10 million, $20 million. This becomes even more compelling. The other aspect I'd like to speak about is getting real-time asset valuations. So there's now agentic AI tools that do pricing. And so very few people, when they look at their asset management systems, understand the exact value of an asset. And they can say, I might know when the end of service date is, I might know some limited information. Very few people are able to pull in real-time value. So what's nice about advancements in AI, lots of agents being built, lots of pricing. If you'd like to look at what is the value of a fully configured rack, when should we refresh it, when's the optimal time to refresh, I need to actually look at replacement cost, whatever the use case is, agentic pricing tools are becoming very advanced. And so the way we look at this is, if you'd like to understand value of the fully configured rack, the units comprised in, or the components or subcomponents, all that's now possible with agentic tools that are being built. This data, too, can easily be integrated into your systems, asset management systems, DSIM, ITSM, any of them. Let me go back. Sorry, guys. Couple of things that we see some use cases for. Lots of use cases on appraisals and residual forecasting. Firms that want to sell in place, they might want to do an early upgrade. If you want to know the exact value of something right now so you could take it to market, harvest CapEx, and put it back into the new project cost. It's a very valuable tool. Sales at retirement, it's pretty natural. And then also at redeployment, you want to say, how do I do intercompany accounting of this? And so it's very important to incorporate what is the true asset value. The thing I mentioned before, this is really just metadata, and you can do a lot of these things agnostically. We don't personally have platforms and tools we recommend. If you're a ServiceNow shop or if you're using one of the DSIM tools that are here, there are a few great ones. You can just take metadata, and the integrations are quite simple. It's basically an API call. RFID uses MQTT. The machine vision just does TCP/IP connections. Integration into your platforms is very versatile. I think getting that deeper level of understanding, once you've trained it, all this data can be integrated into the system. And so we've seen a lot of different requests. We want this in our ERP system or our WMS system. DSIM, ServiceNow is a common one. SAP, a lot of those integrations are native. And so once you get the data, it's just managing metadata through APIs. And so then I think the real magic is you can start to automate workflows and get predictive with some of your decisions, right? So this becomes part of forecasting, planning, next level design in the data center. So that's my time, and yeah, appreciate it. Yeah, thanks.
So our next speaker is Pete Sacco, who's going to talk a little bit about reimagining the data center in the new era that we are in. So Pete, I'll turn it over to you. Thank you.
Thanks, Sean. Get a little acclimated. Hi, everybody. My name's Pete Sacco. I am the founder and CEO of a company, 30 years, PTS Data Center Solutions. And we design and build data centers and energy solutions for the federal government, lots of 3-letter and 4-letter people. This year we built data center for Lawrence Livermore National Labs and Sandia National Labs and NASA. At the enterprise level, a lot of global enterprise people like Pfizer, long since out of the data center game, but have 1,100 sites globally with lots of edge compute. And then some of the data center operators, they'll be the first to admit I'm not the hyperscaler guy, but people like CyrusOne. So we do a lot from the operational side and the new construction side. And so what I want to talk about today is I'm presenting a complete architecture roadmap for what I believe is the most urgent infrastructure challenge of our generation, where we're finding ourselves now. We need to build a sovereign, decentralized digital backbone in order to bring us into the age of AI. I don't believe this change is going to be incremental. I think it's a paradigm shift. And I think today what I'd like to show you is some of the data as to why I believe that to be the case. So first thing, the AI infrastructure, the AI revolution is not software, it's infrastructure. And the numbers are staggering, as you can see. I mean, all of these are kind of arbitrary at this point because they're moving so quick. But you know, S&P Global reports 135 gigawatts of power by 2030. The demand is 2 times 2030, Bain and Company report, and Gartner says $583 billion data center systems, and that's, by the way, up from only 18 months ago. And so the numbers are staggering, as Jeff just alluded to. It doesn't seem any end is in sight, and it will continue to grow. However, the physical constraint is real. You know, power GPU densities are roughly 80 to 120 kilowatts a rack right now. That's 10 times what traditionally has been the density in a rack. The bigger problem is right now is the wait time for a grid interconnect, and that's turning out to be a real problem. It's, you know, I've seen in certain cases 5 years, you know, and that doesn't work when AI demand has been doubling every 18 months. Okay, so here's the inflection point. Because what we're starting to see right now is we're pivoting from training to inferencing. Inferencing is going to be the application that carries the data center into the next century. Training happens once. It's an investment. Inferencing happens continuously and in real time, and it's where you generate your revenue as a data center operator. So for the first time in early 2026, inferencing spending crossed 55% of all AI cloud infrastructure. And McKinsey projects that by 2030, inferencing is going to represent somewhere in the neighborhood of 70 to 80% of all AI compute. But here's where it matters for infrastructure. You know, training tolerates latency. You could put your training clusters anywhere in remote locations where power is cheap. But inferencing is going to require 1 millisecond round-trip latency. It has to be near the user, near the data, near the population clusters. And by the way, inferencing, right, prompting, people. But that's not where the inferencing is going to come from. Where's the inferencing going to come from? Robotics, right? And so if you take a look at where the robotics world is going to go, they are going to inference. I believe what we're going to see is what I call light edge and heavy edge. Light edge is going to be that the robots and the machines, the AI devices themselves, are going to have a certain amount of compute on board to be able to do some inferencing, but they're going to have to federate in a very local way with other robots, other things, the cars that are going to be communicating, the tractors that will be communicating, and then training on one another. And so that is going to have to happen near real time, which will require a different sort of data center. You can't have a 500 megawatt data center sitting in the New Mexican desert and be able to deliver real-time inferencing within millisecond scale. It's going to require a different infrastructure model. I believe it will be a distributed, edge proximate, and it will be purpose-built for it. Okay, so here's the reality, though. We've got 4 problems that are hitting us simultaneously. Power and water. The grid can't scale fast enough. We talked about already that right now we have a delay. It was funny, I addressed by a podcast the electric utility industry, and they asked, the CIO, the presidents of all the interconnects were asking, what could we do? And the answer was, we don't need you to do anything. Because the AI industry is not going to wait for you to solve the problem. The AI industry is going to solve the problem for itself. They're going to become particular as to what is the energy that we can consume in the particular area where we're going to do it. We have sovereignty problems. We're seeing, data and geopolitical risk rising throughout the globe right now. And in the United States, we're the last one. There's over 100 countries have sovereignty laws right now, and we don't. We have trust-based sovereignty. Your data is somewhere on the East Coast. And I could tell you for my federal clients, for some of the applications it works. For the majority of my Department of Energy and Department of Defense, that no longer works. Nor is it going to work in regulated industries. We're going to force to have true sovereignty, and not sovereignty of somewhere in the East Coast. I'm talking cryptographic, understanding, auditable trail about where your data is with true TPM attestation. And so third, we talked the political fallout. I mean, I'm standing here and I'm looking down the street, and there's already people talking about, protesters about data centers right now. That's why 50% of data center projects in the large scale are either being canceled or delayed right now. Not just because power, water, but because there's political fallout right now in projects in general. And so that is the third one. The fourth one would be the latency itself, where I talked about it. Right, we can't have inferencing from regional data centers. They're going to have to be local. But at the center of it all, you have the public cloud. Today, 65% of all global cloud is controlled by just 3 companies, right? AWS, Google, and Microsoft. And to me, that's a structural dependency that can't last into the next century if we're going to realize AI completely. To dig in a little bit deeper on the sovereignty issue, it isn't a compliance checkbox anymore. To me, it's a matter of national security. And the regulatory landscape is growing. We see the GDPR law rules in Europe, and NIS2 and DORA push operational resilience for critical infrastructure. The US executive orders created new AI safety mandates, and China's laws restrict cross-border data transfers entirely. But here's the gap. The current cloud providers offer trust-based sovereignty. They tell you your data is in a particular region, but there's no cryptographic proof, no hardware attestation, no immutable audit trail. True sovereignty is going to require cryptographic proof through TPM attestation, right? Immutable logs that regulators can independently verify, and hardware root of trust through Intel's like TDX or AMD's SEV-SNMP and zero vendor lock-in. Gartner values the sovereign cloud market as being $37 billion today, but growing with a 36% CAGR, right? That's $170 billion by 2028. To me, the broader sovereign cloud market is going to exceed probably $1 trillion by 2035. And that's not a niche, right? That's a massive accelerating market. So the answer isn't bigger centralized campuses. The answer is distributed and decentralized. So what I'm showing here is basically at the top, we have behind the meter power to solve the power grid problem. We can't wait 5 years for an interconnect. What I think we're going to see is opportunistic creation of power parasitically at the building and or the campus. You will generate your own power on site. And the way I think that roadmap is going to look, it's going to look exactly like this. Electrical interconnect giving away to natural gas creating electricity at the side, probably a proliferation of hydrogen going to small nukes. Small nukes are probably 8 years away, 5 years of development, 3 years of certification, and then that will give longer term way to fusion. I think the day of the centralized utility is gone. I think we're going to actually see that we're actually going to even do fusion, though you're seeing Commonwealth will probably bring its tokamak reactor on in 27, about 100 megawatts only. I think what we're likely going to see is micro nukes and hydrogen and electrification and improvements in solar, after they actually add perovskite to things to get more than 18% of the sun's energy. We will be opportunistic and we will create energy at the building's edge. Edge distribution, I think, is going to be, I would tile the planet with, call it 2 to 20 megawatt data centers in what I like to refer to the high school football cities of the world, right? Think about this. The hyperscalers sit in the American pro football cities of the world, New York, Chicago, Dallas, Los Angeles. The data center industry as a service intends to sit in the NCAA cities. Sorry, I'm an ex-football coach, right? So everything has to have a football connotation. And then what we're going to do is we're going to tile the planet with high school football cities. And we're going to put these small data centers, and we're going to put them everywhere, in essence, decentralizing data center ownership. Why? Because we need to be better than 10 millisecond round trip, and we can do that locally, we can do that regionally. Let's say 5 millisecond in a region, like say central and northern New Jersey and New York City, but then when you have a data center in Totowa, you're 1 millisecond from Bergen County, Mercer County, right, wherever where you are. That gives way to the sovereign cloud. We're going to talk a little bit deeper about that, but that's a multi-compute, composable cloud per region for compliance, where each facility is going to operate under the local jurisdiction of the cryptographic enforcement that it's in. And then finally, we have, on top of it all, a federation into a unified platform. And these would ensure that we have independently owned and operated sites, and that they're going to connect through a common protocol, create a network more resilient than any single hyperscale campus can provide. This is the architecture that I'm building right now. And what I intend to show you is what the complete stack looks like. And so it basically is the sovereign AI infrastructure backbone. 4 integral layers, each building upon the one below, and we'll start from the bottom up. So we talked about the energy foundation. This is where we're creating resilient sovereign energy infrastructure, either grid interconnect, microgrid, solar, BESS, behind the meter. You're going to see the example of the property I'm doing right now, where we'll actually create the power behind the meter, sell it as a service, and to the data center. But these here in this small scale, I don't have the problem of using the no longer available gas turbines. Here I can use solid state fuel cells and or mainspring energy. In fact, the speaker before this talked about mainspring at linear generators. We're also making it far more sustainable by using waste to energy solutions, pyrolysis, which has been around a long time, not incineration, but melting carbon to its base syngas components, and then melting the rest down into a slag or rock, an inert gas, and in essence lowering the cost of the production of energy below what the electric utility could provide. Engineered for 95% gas independent, grid independence. That's really the goal. The next layer up is the data center facility layer, number 2 there. That's the purpose-built AI optimized infrastructure. That's what I've been doing at PTS for the last 30 years, is designing and building these facilities. And so what we're talking about here is the high density cooling that is required, the direct liquid cooling, the rear door heat exchangers, the geothermal integration, 2N power distribution, achieving 80 to 120 kilowatt rack densities in a form factor of about 5 to 20 megawatts per facility. My idea is that to deliver this, interestingly, in a franchise model. What I want to be able to do is build Grey Wolf data centers to actually deliver this so that companies and or people who want to be a part of the data center movement can actually build in the region that they are, with the space that they have, with the power that they have, and contribute to what will be 10 to 30,000 independently owned and operated data centers serving a decentralized and data sovereign public cloud. In essence, taking the cloud back from singular ownership by a company or a country or an institution and moving it back to the people. The idea is that each of them would be completely independently owned and operated. So you can't do this unless you have number 3. Here I'm calling it the Grey Wolf Luminix Cloud, because that's the cloud platform that I'm building right now. It's a sovereign, high-performance cloud environment purpose-built for AI inferencing through a composable multi-compute fabric. Not just GPUs, a heterogeneous architecture that matches the workload to the compute needs of the physics of the workload. And then finally, up at the top, you have Atlas Cloud. Atlas Cloud is a DAO, a distributed autonomous organization. It is what provides the orchestration layer. It's a decentralized cloud architecture that extends sovereign infrastructure beyond any single facility, enabling a federated, resilient AI deployment at a global scale. Think Bitcoin for data centers. There's immutability. It will serve, and we're going to delve a little bit deeper into it, but the idea is that these four all build upon the layer above them in order to build what we're talking about is a complete stack from the electrons at the bottom all the way to governance at the top. Okay, so at Graywolf, this is what we intend to do. So the first proof of concept that I'm doing with Justin sitting right there, brought him, of the 12 people here, I brought one. And so what we're doing is we bought land in Connecticut. Why Connecticut, you might ask? Well, Connecticut has no data center industry. Why does data center no industry in Connecticut? Well, they have a power problem. The governor knows all too well, Governor Lamont, 30 cents per kilowatt hour. Who the hell would build a data center at 30 cents a kilowatt hour? But what we've done is we bought land, and then what we did is we've improved the land because it's near gas, and we took a pyrolysis plant, convert waste to carbon-based waste, anything carbon, from tires to medical waste to food, and then we apply heat without oxygen, melt it down, turn it into syngas and slag, and then we combine that with natural gas, we carbon capture off of that, turn that into CO2, we get tipping fees from all the local towns in order to bring their garbage, also helping Connecticut. Why? Because what do they do with their garbage? They ship it to the southern states, right? And then we take the carbon and we sell it to the local hospitals, the carbon dioxide. We take the waste heat that comes off of there and we either do vertical farming or we put it into an absorption chiller, or we actually, in recreational ones, we've put it in pools, we've done it in lagoons. And so you could use the waste heat. And then the newest one, a company I'm investing in right now, is using low-grade heat through a modified Rankine engine to create more electricity off of the waste heat. In essence, what I can do is I could produce electricity sub 10 cents kilowatt hour. I could compete against the utilities at that. And I've de-risked it at the power level. Why? Because I could use it for a data center, or I could sell it to anybody. It's a piece of property. So I put a core and shell up there, and if I get a data center tenant, great. If not, I could sell it to a manufacturer, and I could sell it to him for 20 cents a kilowatt hour, and I look like a superhero, right? Because it's paying 29 cents a kilowatt hour normally if he has to be in Connecticut. So this is the Graywolf AI native facility, and this is what we'll do, and we'll build this as throughout a region. So instead of having a 1,200 megawatt data center, right, which there is no more places for that anymore, I could build 120 10 megawatt data centers in a region, glue them all together, and actually control the most important region, what we call the Northeast Corridor. So this is what we're doing today of all of the stack that you saw before. In essence, the idea is to be the Starbucks of the data center industry. Some of them will be company owned, the majority of them will be franchise owned, some of them will be independent, but they will all operate on a DAO, and they will all operate using that same cloud approach. And so what does that cloud approach look like? It's an eye chart. But you got to remember, I own PTS and I'm building Graywolf Data Center, but I also am a fairly prolific venture capitalist. And so what do I invest in? What's my investment thesis? All of those companies right there. And so if you take a look at it, Lemurian Labs basically is building the replacement software for CUDA. Who's CUDA? CUDA is the software that the GPUs from NVIDIA operate on. Who's the largest investor for me? AMD. Why? Because AMD probably builds, is there anybody from NVIDIA in here? Good. They probably build a better GPU than NVIDIA, but NVIDIA builds better software. So they know that, so AMD is investing in Lemurian, and we've built a singular piece of software that could actually replace CUDA full stack with anybody's GPU, and I can actually orchestrate it there. We've also improved it such that 4 times greater saturation of the chip than even CUDA will do, meaning instead of 15% utilization of the GPU, I'm using about 50% utilization of the GPU. But remember, I don't want to do this just for actually large model training. I want to do this for inferencing. So I'm building also the cluster. So I can also increase the utilization of the cluster, meaning data center to data center to data center interconnectivity of the chip use. And so singular software. Below that, we have Liquid AI, the transformer, not electrical transformer, the GP, the T in GPT, the dynamic transformer. Most transformers are static. These guys have invented the neural networking equivalent of a dynamic transformer, the ability to train on the fly. Inferencing, I believe the world is about to get much smaller than bigger. And what I mean by that is instead of large language model training on vast amounts of public data, we're going to use private industry data, and you're going to train on your specific data, and you're not going to want to put that in the public world with no data sovereignty. You're going to want to put that in a data center to know exactly where your data is and where it's using and where it's auditable. And so small language models are going to be self-referencing in that they will be near real-time training and inferencing on your data. And so going one down from here, the heart of this is Cirio. He will be my partner, Phil Harris, in building this cloud. And Cirio is a Canadian company, one of the countries that has true data sovereignty, by the way, that they've come up with an optical software-defined CDI, meaning I can actually take many different types of compute. So you'll notice down here we've got GPUs. That's where my dense training and inferencing of what the world is using today. Except I could use anybody's, not the latest, greatest. I could use any version, anybody's GPU. And I can combine that. We'll skip TSUs a second. We can go to RISC processors from TensTorrent, or CPUs for serial processing and orchestration, or FPGAs if I need flat out performance and I want to build an ASIC. But let's talk about probably my largest investment, Xtropic. Xtropic. All right, let's geek out a minute. CPUs, GPUs, FPGAs, deterministic workloads, meaning they calculate a 1 or a 0. Quantum computers, non-deterministic, meaning they can hold in their stack a value between 0 and 1. Let's forget why that's really good, but mathematically that's really good. It gets us really fast compute. But the problem with quantum, it uses quantum mechanics. Just the electron jitter alone throws off the accuracy. So what do? We use superconducting materials and we freeze it below 0. In order to freeze it, we're probably a decade, maybe 2 away from making that commercially available. When I started to investing in Gil's company, Xtropic, I thought it would take them 5 years to come up with a room temperature. 18 months. We're in production right now with the world's first non-deterministic chipset that actually is at room temperature. It's being done in partnership with Taiwan Semiconductor. We will have our first tested and available in September, and we're taping out with Samsung and Global to have 3 simultaneous manufacturers. You ready for this? 10,000 times more energy efficient than a GPU at running a probabilistic workload at twice the speed. We're going to change the world. The data centers that we're going to require tomorrow will not use the technologies of today. What we need to think about is what the technology is going to look like. At the end of the day, along with you're seeing confidential compute and verifiable inference, meaning sovereignty, I estimate that we'll have somewhere between 60 to 80% utilization of the chips and of all the compute, because we will match the compute exactly to the workload. I will have dynamic allocation, and you'll have bare metal performance locally within 1 millisecond round trip. Okay, so Atlas Cloud is the culmination. It's the full cloud performance platform layer governed by a decentralized autonomous organization. It's in essence the protocol pillar that delivers everything that you would expect, from a serviceability standpoint, every type of storage imaginable, and whatever data and AI services platform. It will also serve as an identity and sovereignty platform as to jurisdictional control as to who's operating in the data and where and how you're going to get paid for contributing your compute, storage, and services and networking to the cloud. And then lastly, we built into this is tokenization and governance. Tokenization, real-world asset tokenization, meaning as you come in as a franchisor, we're going to assist you to actually raise capital for your data center and cloud project, because we'll open it up as a token platform to the other. So also in the world, I own some of the patents around real-world asset tokenization in blockchain. But of course, they were all infringed upon by Securitize and so Blockforce. So the U.S. government is likely going to consider my patents null and void as unenforceable. But that's the world that we live in. But the truth is, I still have the technology for it. So if we build the DAO, I think that's how we actually get decentralized ownership of the data center. And for the layperson, I like to say this. We need to stop being in a world that if you're the person with the stupid little cat videos that got 8 million views, that Google makes all the money, and then they own the cat video, and then they distribute. If you own the cat, you should get the lion's share of the money. YouTube or Google, whoever it sits on, that should be the commodity, and that's who should get the pittance. That will change. In the AI era, everything will decentralize. Are we seeing that already? How about this? After COVID, do we all work in the same place anymore? No, we're spread throughout the world. We've learned we can live with a decentralized workforce. In fact, I'd actually say that majority of people now are doing more than one job, working for more than one company, doing more than one thing at one time in order to decentralize their life. How about in the world of finance and currencies? Are we seeing cryptocurrencies and decentralized finance take over as perhaps the new dollar? Love it or hate it, decentralized finance is kind of the trend right now. I think we're seeing this in energy. We just talked about 2 minutes ago that the era of the centralized utility is going away in favor of creating energy at the edge facility for the campus or the site. And I think we're going to see that in data centers, and that is going to usher in the era of the decentralized data center for public cloud. So let me bring it all together. The architecture is complete from the energy sovereignty through the behind-the-meter generation all the way to the AI-optimized facility infrastructure to the Luminix composable multi-compute fabric cloud with everything from GPUs and CPUs to Extropic's thermodynamic scaling unit. That's what we call it, a TSU. And then with Liquid AI's dynamic neural networks and Lemurian's federated orchestration all the way to the Atlas Cloud DAO to provide governance. The economics are compelling. When I do the behind the meter, my negative fuel costs, because of the waste to energy, generate tipping fees revenue and 60 to 80% hardware utilization. 3 to 4 times what traditional architectures achieve from a percentage of hardware utilization. We will have transparent cost plus pricing with no egress fees to pull your data outside of the data center. And you'll have, as an operator, you'll have 7 or more revenue streams if you're a data center operator. The sovereignty guarantee is cryptographic. It's not contractual. It will have real hardware-based attestation. It'll have immutable audit trails and customers and regulators can independently verify. And it will be policy-enforced jurisdiction control, standards-based portability with 0 vendor lock-in. Look, this is not an incremental innovation over the data center. This is a paradigm shift that the world will require if we are to realize AI the way AI is. AI, if it was a 24-hour clock, we're at 2 a.m. We've got 22 hours left to go. By noon, we are not going to recognize the world. All right? And so it's going to require a different era for what the data center industry is going to look like, and it will be different from the last era. Inferencing at scale requires a distributed, sovereign, purpose-built infrastructure at the edge, and that's what Grey Wolf, Luminix, and the Atlas Cloud will deliver. Am I right? I don't know if this is going to work, but we'll try it. And so recently, Peter Diamandis owns the Moonshots podcast. It's a big podcast. I got to ask the last question at the thing. Let's see if it actually works. It's not going to work. But anyway, the answer was the guy sitting to the left is Alex Wisner-Gross, one of the leading quantum physicists in the country. Next to him is Dave Blunden. He owns Link Ventures. He's basically 85% success rate as a venture capitalist by going to MIT, taking 3 friends and turning them into multimillionaires by figuring something out that they're smart and ask them to build it. And that's Peter Diamandis and the rest. And so I asked, I'm like, Elon Musk's president of SpaceX was there, and she said, we're going to build 1,200 megawatt data centers. So I got up and I'm like, where? Where are you finding 1,200 megawatts, contiguous anymore? It's not available. Why not build 120 10-megawatt data centers in a region and do it that way? And Dave goes, Pete, I think you're right. Yeah, you're probably right. No, I think you're right. You just need to go to every governor in the world. I could tell you, I'm talking to lots of governors right now. They want small data centers. They don't want massive data centers. They want the tax revenue. They want to be a part of the data center revolution. The only way that we realize this is to have decentralization and sovereignty. And so the AI era is here, and the global data center demand is going to be huge. And I think sovereign cloud market is headed past $1 trillion, and the centralized hyperscale model is not going to do it for us. We need something different. That's what I hope to be able to deliver. If anybody has questions about it, I think we'll do it outside. Thank you for your time. I appreciate it. Nice to have met you all.